Hello, this is Malban again, and again I did a little stuff for Isidro, and I would like to show you what I did. For that we open Vide again, and what I did is a little bit optimization to the vector lists. I hope this works out as well as I think it will. I will just show you for an example, and for that I load an animation that Isidro did, the interior. We take this one. This is a pretty large vector list. It has 252 vectors, and you see this is also new. You can see how many move vectors the interior has, 71. And I would like to optimize this for better or more efficient drawing. So I can show you what I actually did, or that it's actually optimized. I will draw the thing as I got it from Isidro. Draw synced list, runnable, otherwise it cannot run, and run it. Run it over here in Vide, and I will open a tracky window that shows us how fast or how slow it is drawn. Now it is drawn with 53,000 cycles, more or less. That is a little bit more than 25 Hertz. So it's on a real Vectrex, it is really flickery. And the gist of the thing is that the vectors should be more or less connected. Pretty optimal it would be if 20 vectors would always be drawn in a row. The synced list always draws the vectors. Oh well, anyway, this is a generated vector list, and you see there are many syncs in between, and it's not very efficient. For a list of 200 there should be 10 syncs, or about 10 syncs altogether, and there are quite a bit more. Also, the vector list is not optimized for size. The current size, here you see the sizes in the list. There are many sizes that are below 50, for example, and quite a few only that are 100 or above. So the actual size of the vectors is optimal if they are near 127, or at least a large number of them. So there's also room for optimization there. So for the new optimizations, I created a new tab around here, shortcut 2, and we can do pretty little things here. So first we can do is disconnect all vectors. The pink vectors over here, they are all connected somehow in some path. We can disconnect them all. That is actually a pessimization. If I draw it now, it's probably even slower than before. Just can look at it. Before it was 53,000 and now it's 50,000. Funny. It's actually a bit faster, I guess, because now there are no move vectors in between, and the synced list can handle all moves on its own. It does not rely on moves that are already in the list. Don't know. Actually, I haven't investigated it why it's faster already with this. What we can do, I said there are 71 move vectors. They are still in the list, but not needed anymore. We can remove all move vectors. If you just press this button, the disconnect all is also executed. So there are now 181 vectors. Might be a little bit faster already again. Let's look at it. Okay. This is actually funny. I don't know why it's slower now. Anyway, the gist of the thing I'm going to show you is a combination of all these buttons, and the combination of all of them is actually quite a bit faster. So, something else, we remove double vectors. There are, I think, only 2, but anyway. Double vectors means the vectors are exactly the same but double drawn, so they are not really enhancing the vector list in any way. And there's also a button remove I double vectors, that is inverse double vectors. So if one vector goes from here and one from the opposite direction but otherwise the same, it's also removed, but there are no such vectors. Then there's also remove dots. If there's just a dot in the drawing, you can remove it with this button here. This is 3D dots. All three coordinates x, y and z must be the same, then it's a dot. You can also remove dots, two-dimensional dots. Then all the the depth vectors that are not shown now would be removed, but per default that is off, and for 3D rotation that is that you want to generate, it's not really useful. So with all this, this is a totally disconnected vector list. There's no connection at all. So in principle it is very unoptimized, but there are two new buttons over here: connect the longest path and connect the longest path ++. Connect the longest path is a routine I wrote that is actually iterative, that goes through all vectors and looks for optimal paths. So if I execute this button, there are, I think, 50 optimal paths. The largest path is 26 and the smallest path is 1. So there are some vectors which are left alone. And the longest path ++ actually connects these longest paths. This button generates a vector list, a complete connected vector list from this drawing. This is what we do. And actually this takes a little while. On my computer it takes, I don't know, 20 seconds, so I just start it. You will see this drawing will at some point go completely pink again, and then you see that all vectors are actually connected. Okay, now we're there. We will execute it again. You see, draw VL mode is even highlighted. That means that the complete vector list is connected. Draw runnable, draw simplist, and execute it. Now we are already down to 39,000. You can still optimize that a little bit with this button over here, optimize size. Optimize size is what I mentioned before, that these vectors have lengths that are not optimal. The optimize size button will probably do is cut the long vectors into half or third and actually increase the vector length of the short vectors, so that the optimal relation is found between the length of the vectors. This again takes a few seconds. I will execute it and you will see that these sizes will change. Here you see it too. The actual interior is drawn quite a bit larger within this grid, and you see these lines are now halved. If I execute it again, it looks like it is a little bit slower actually. $46,000, but the interior is quite a bit larger. To compare it with the other one, we have to resize it, resize the scale, so that we actually can compare it. I'll take a step back and draw it again, so we can see the old list again. So it's from here to here. Just remember that. This one here, this one here. Take back, draw it again, execute it again, then you see that it's quite a bit larger. and the optimal size, there's a number over here that is 2.1. That means that the actual scale factor can be reduced by 2.08. This is what it's. This image is actually about double the size as a image before. So what we can do here, don't worry, you don't have to do that, but it's for the example that we can compare it. This is a scale of the actual vector list, and 2.1 is about 1e. The half of 40 is about 1e, at least. Okay, the 0.8 respected. Then we can execute it again, and we see that the actual created vector list is about the same as the original vector list, and again we are a little bit faster. Now we are at 38,000. So actually we optimized with a few clicks in the GUI the vector list from, what was the first one? I think something in the 50,000s, and now it's 38,000. If this is all that you want to draw, and you do not want to draw a 3D image of that, you can reduce the dots. That's what I said before. Reduce the dots because the actual 3D. Okay, no, you can't see it here. Wait, can do that a little bit smaller. Scale it a little bit down. What you see is that these Z, these ones here, if looked from the front view, they are dots because they go inside the screen. If you only want to view the front, you can remove these because they are dots. We switch this to 2D dots and remove dots. Then you can see now we have 265, remove dots, 213. If we do that as a synced list, it's again quite a bit faster because all the depth vectors are now missing. So now we are at 36,000, and we could probably still optimize it more because it's only the front, so the complete back could also be optimized, but I should do a button for that, remove double 2D vectors, and then the vectors behind would also be removed. I haven't done that button, but it's probably not needed all that much, or I'll do it later. I don't know. So this is actually the optimizations one can do now with these shortcuts. Another thing Isidro asked me, or no, he did not ask me, but I interpreted his messages, that he would like to have a 2D rotation, a selected vector list rotation. One can now do that also. We go to this view again, and somehow this is okay. We select vectors now with with Shift we can select a bunch of vectors. So now we take this leg, or whatever you want to call it, of this interior, and we can do a rotation of only these. This is a new button here, selected rotation. This only works as a mode is vector, and to take these values above here to do the rotation. So I can switch on which axis I want to rotate, and the rotation value, and if clockwise or anti-clockwise. And if I now press the button select rotation, then the selection rotates. I forgot one vector list, but yes. The thing you should also remember if doing rotations is that the rotation, or at least the result of the rotation, is always taken as integer values, and so if you do in this example a complete turn or of the circle with the angle, it's probably not exactly the same coordinates than ones you started with, because there are bound to be rounding errors. Well, I think this is the new stuff I did today. I also changed the storyboard a little. The picture up here is missing and the timeline, because I haven't figured out how to make use of the picture, and I haven't figured out how to use the timeline appropriately. And also there are default values now, so you can start right from the beginning and don't have to enter too many things. So add lane, just for example, and we load the interior we just had here, and you can start right from the beginning. There are sensible default values within the value section above here. So these are the things I did, and I think I will pause with Vide now for a little bit, because my holiday is over and tomorrow I start work again, and I probably won't have that much time anymore. So these were the last changes. Thank you for watching, and bye!